So we're now ready to explore another new type of function, polynomial functions. So let's begin by reviewing the definition. We want to let n be some non-negative integer. So we have n is an integer value that must be greater than or equal to 0. In addition to this, we want to let this set of a values all be real numbers, such that the first term in this set, a sub n, cannot be 0. So with this information, we can say that a polynomial function of degree n is defined as follows. So a polynomial function of degree n is defined as y is equal to f of x, where this is equal to a sub n times x to the n, plus a sub n minus 1 times x to the n minus 1. And we continue merrily along here, all the way down to a sub 1 times x to the first, plus a sub 0. And technically, this is a sub 0 times x to the 0, but we of course know that anything or x raised to the 0 is 1. Now, be mindful here, all of these a's that came from this set, these are the coefficients of our polynomial function, and the coefficients must be real numbers. Additionally, notice here how the exponents on x are these non-negative integers. So the exponents of x must be whole numbers or counting numbers beginning with 0. So what are some examples of polynomial functions? So here are two examples of polynomial functions. Notice that all of these coefficients are real numbers. Even the square root of 2 and 1/2, these are real numbers. In addition to this, also notice how the exponents on all of the x's are whole numbers. So what are some examples of polynomial or functions that are not polynomials? So here are 3 distinct examples of functions that are not polynomial functions. Now, why aren't these polynomial functions? So looking at our first function, f of x, notice that this function contains the square root of x. And watch what happens when we rewrite the square root of x in its exponent form. We see that the exponent is 1/2, which is definitely not a whole number. So this violates the definition of a polynomial function. So what about g of x? Why isn't this a polynomial function? And again, looking at the terms, we realize we have a rational expression here. So if we rewrite 2 by x cubed in its exponential form, this is equivalent to 2 times x to the -3. And just like with the first case, we can observe here that the exponent of x is not a whole number, making this a non-polynomial function. And last but certainly not least, what about h of x? Why is this not a polynomial function? So this time, take a look at the coefficient. The coefficient in this case is a complex number. It contains the number I, which violates the definition of a polynomial function. We know for polynomials, the coefficients must be real, so they cannot be complex. So now that we've explored some examples of polynomial functions and functions that are not polynomial, let's go ahead and explore some more familiar friends that relate or that classify as polynomial functions. Now, while polynomial functions technically classify as a new type of function, we're actually already familiar with several special cases of polynomial functions. So to help remind us of these cases, let's consider the following functions. So a constant function is our first example of a polynomial function that we're familiar with. And I have the example f of x is equal to 2, which graphs to the horizontal line. And while at first glance this might not look like a polynomial function, keep in mind that we can rewrite this as 2 times x to the 0, because we know that x raised to the 0 is 1. So for constant functions, we say that we're working with a polynomial of degree 0. Another polynomial function that we're familiar with is the following case. So linear functions are another special case of polynomial functions that we are familiar with. And up on the board, we have the example f of x is equal to x. So we know that this is the same thing as saying we have x to the first power. So this linear function, and all linear functions for that matter, classify as polynomials of degree 1. Another example that we're familiar with. So quadratic functions are another example of a special case of polynomial functions that we're familiar with. And up on the board, we have this squaring function, f of x is equal to x squared. So in this case, we would call the parabola, or the quadratic function, a polynomial of degree 2. And last but not least, so cubic functions are a fourth example of a polynomial function that we are familiar with. And up on the board, we have the example f of x is equal to minus x cubed. So looking at our whole number exponent, we can say that cubic functions are polynomials of degree 3. So these are just a few of the common examples of polynomial functions that we're familiar with. So now that we've seen the definition and seen a few functions that we're well versed in, let's go ahead and begin to analyze the characteristics of the graphs of polynomial functions.